The discussion would be around the landscape of some of the technologies which has a lot of momentum in 2026. So we'll be focusing on that and how that can be utilized onto the smart contracts, and particularly with the viewpoint of developing carbon negative protocols for understanding the smart contracts in a better way. So putting myself on mute, we'll start in a while. Okay, so first of all, the tech or the processes in place from the viewpoint to tackle few of the major problems right now. One of the major problems is air pollution. Global warming is real, and since global warming is real, we need to mitigate the nuance around the landscape of what is being developed in terms of the problem statements. So, one of the major problem statements which India and the other countries are going through is air pollution, and we will start with the tagging process. We'll try and put it onto the smart contracts. So, for this month, my personal focus is on developing smart contracts around the air pollution and drafting the smart contracts and mitigating the risk in terms of the SWOT analysis. So that is what I wish to do for this current month. Okay, first of all, we will try and understand the tagging part of it and the beautiful advantage or the wonderful advantage of understanding the classification of the words itself. So, here the words, the language is English. So, it's very important, first of all, to identify the air pollutants which are causing the problem in terms of the respiratory ailments and the like in the human population. So, first of all, we'll talk about the classification in terms of understanding what tech can be deployed first for the identification of the pollutants. Second is how that can be mitigated. Third is how we can make the air more breathable, how we can deploy the overall tech onto the smart contracts, how that can be part of the blockchain, and how um, at the same point of time we can go back to be carbon negative. So these are the mission statements for the month of December 2025, and particularly I'm of the opinion by 15th of December we will have some kind of consensus on the same, which can be utilized and deployed for the rest of the days, and that itself can become use case studies for the deployment at a large scale network. Okay, so one is preparatory treatment of cellulose for making derivatives thereof. That is, it includes three kind of processes. First is pre-treatment, pre-soaking, and activation. C08B1/00. Then we have treating solid fuels to improve their conversion by heat treatment. Then we have monosaccharides C12P19/12. Okay, shielding of cells or rooms, that is G21F7/00. Gas solid is B021J2219/0886. Next, we have applying radiation such as microwave, IR, and UV, C10L2290/36. Then we have biofuel, biodiesel, Y not 2E50/10. Sunlight, which is abundant right now, is Y not 2P20/133. Then we have processing objects on a macro scale, H not 1J 2237/31. So this is done. I'm just trying to understand what are we trying to do. So basically, this particular arrangement is to destroy the ozone. Um, it's a method of conveying a metal or material. So material itself could be different kinds. But let me see whether I want to discuss this or not. We are utilizing nitrogen, so I don't want to get into the ingress and the egress part of it. Um, or we can just move on to the next one. I personally believe removing or destroying the ozone itself is not going to solve the bigger problem. Maybe in silos or in as an experimentation, it's good. So probably let's look back to another application and see how it works. If you have any questions, you can put your questions in the comment box. We'll try and answer that. But somehow I feel doing the smart contracts, drafting it around the same wouldn't be of much use. So we'll move on to the next application. कोई एक्टिविटी नहीं कुछ नहीं मैं कार्ड रुक जा ऊपर ऑफिस में पता है कार्ड ले Okay, we'll try and talk about this. This again is talking about, we have, this is IAQ. IAQ is indoor air quality. Particularly, the indoor air quality can be utilized at least to draft or have numerical formula around creating the controls, which is important. And then we have something I've been working on for a while. Okay, so this is basically HVACR. H stands for heating, V stands for ventilation, A stands for air conditioning, and R stands for refrigeration. And then we have MCAC, that is multi-containment air cleaner. Okay, so loads of sensor and the others. Let's first look into the systematic classification of the same, and then let's see how we can utilize it for the smart contract. I think this I can use to draft smart contract because that is something I have to prepare a use case study for solving the air pollution problem. So the point here is whether I should take certain areas to be resolved at the first chance, or probably it can be done at a large scale. That needs to be done. We need to see the results for that. Okay, so here we have filters. So a lot of filtering system has to be deployed when we are trying to curb air pollution at the first stance. So for that we have B01D46/0036. It is filters or filtering processes modified for separating dispersed particles from gases or vapors with additional separating or treating functions by absorption or adsorption. Then we have filtering means for treating functions provided with antibacterial and antifungal means, that is B01D 46/0028. Then we have all air systems, F24F3/044. Controlling adsorption, that is B01D53/0456. Ozone is B01D2257/106. Um, okay, so if we are talking about the parameters which should be taken into consideration when we are trying to understand and mitigate the air pollution at a large scale, um, is temperature, humidity, air quality parameters, airborne particle content, VOC, that is volatile organic compounds. Then we have carbon dioxide, carbon monoxide, and the others. So these parameters are also taken into consideration when we are calculating the stuff. Then for the treatment part of view, we have treatment example purification of air supply to human being or working space. Otherwise, it can be done utilizing heating, cooling, humidifying, drying, or sterilizing using UV light. It's F24F8/22. This is done. Let's look into the other aspects. Okay, let me look into the flow diagram. So here, as I said, we are looking into IAQ, that is indoor air quality, whether it's meeting the requirement or not. And then we have a multi-containment air cleaner, that is called as MCAC. So it's more of a loop in terms of you obtain the sensing data, then there are a few determination if it is looked into the data set whether it meets the requirements or not. If it is meeting the requirement, then we see whether it meets the requirement of IEQ. So it is predefined what is allowed and what is not allowed, and then the other operations are increased or decreased in terms of cleaning capacity. So when we're talking about the cleaning capacity, it is um, multi-containment air cleaning operations. So, okay, let's look into the impact of this. Okay, give me a moment. We'll talk about how the method is being deployed. So we do have HEPA filters, that is high efficiency particulate air. Okay, so first and foremost, we need data when we are trying to understand the air quality parameters. So for the sensing data, we have the variables such as temperature, humidity, and the like. Then we have the sensors in the air cleaner side, which is looking into the air quality variables, that is particles, VOCs, carbon dioxide, and the like. There is a controller which has a processor to look into how many air changes in the supply happens to keep the people comfortable. That is, minimum air change is the quantitative measurement which is taken into account. Then we are trying to understand the equivalent air changes which contributes to IAQ, that is indoor air quality. Then the controller is able to decide whether the total air change target is already met or the IAQ score is good, or we need to throttle back to save the energy. Now, how the energy is looked into on how the calculations are done. We are not achieving carbon negative in this case, but it's just a use case study to understand what can be deployed just to make the use case studies feasible at the first place. We are tracking how much energy each subsystem is using, how much history it utilizes to predict the cheapest way to hit comfort and IOQ targets for tomorrow, and optionally show the energy split on a dashboard. So dashboard itself is very useful, dashboard with color coding and with numericals in terms of generally it has been 0 to 5 or 0 to 10. However, I feel if we take the number game from 0 to 100, we would be in a better state to position and identify the errors, because identification of error itself is a very important submodule when we're trying to mitigate the air pollution. So next, we'll go back to another application right now. I think we are good with this. Just give me a moment. I'll look into the carbon negative part of it, if any. Okay, for IoT to be understood with the quantification of the air quality, it itself is a big business model for 2026. So, how we can utilize this is to understand QoS, that is quality of service. Now, to understand the networks, so let's start with P2P, that is peer to peer, H04L67/104. Then we have MTC, that is machine type communication, H04W4/70. Then we have network attached storage architecture, G0 6F16/1824. Discovery or management of network topologies. Um, Okay, multi-protocol handlers, single devices capable of handling multiple protocols, H04L69/18. Then we have, okay, parent-child concept. I would rather say when we're trying to look into these natural calamity problems, the parent-child concept or the hypothesis doesn't work well. It works well when everybody is on the same page. So we did run some protocols, and according to the protocols, what we observed was that peer to peer, when the data set, most of the data sets are same, that is where uh, the collective reality comes into picture. So that is something one needs to look into. So this is done. Let me see if I can get that. One more discussion and then we end this video live. Okay, we have something around digital twin. We'll just go through this and see if this is of any value. But this is something which just caught my eye right now. Okay, for the interfaces, neural network logic, we have B25J9/161. Then we have dual arm manipulator coordination of several manipulators, B25J9/1682. Then we have fleet control G05D1/0291. For allocation of resources, example CPU, that is the central processing unit, request and the like. Terminals is G06F9/5055. Then we have business processing using cryptography, that is G06Q222000. This is something of my interest. Probably the next, if I do one more live, we'll be looking into this understanding. Okay, so I have a basic understanding of the warehousing part. So warehousing is basically where the handling happens. The handling facilities are part of the warehousing, and then there's fulfillment, and the delivery system models have to be deployed. And in the delivery system model itself, when we're talking about the dashboard, we need to have the destination customers, retailers, and the demand environment. At the other end of the spectrum, we have the product, the produce, where we need to have the supply environment, which includes the point of origin, the suppliers, and the production. Okay, how the digital twin is coming into picture, that is something of my interest. So I'll just look into that aspect and we'll just give a closure to this. Okay, in this particular embodiment, we have different workflows to be managed, and then we have a set of distributed manufacturing network entities, then a set of digital twin, which is generated by the platform, an AI system. Oh my gosh, so much work is being done on every 24 hours. I mean, I use one particular web domain to create something. The next day, if I just do a little bit more research, I see a better option. So that's how fast the AI modules are right now. And there's no point, creating something out of the box. What is important is how you're able to utilize the given sources and create something out of it in a fast, speedy manner and solve the problems which are at hand, the bigger problems. Um, in terms of primary, secondary, and tertiary market research, I think if you just concentrate on the primary research itself, there's a lot of work around the primary research because whatever has been done is falsified data, or I would rather say synthetic data that has no value altogether. Okay, so the AI module is executing a data processing module in communication with the platform, training to generate process parameters for the workflow using the data collected from the network entities. Then there's a control system configured to adjust those process parameters during an additive manufacturing process and performing at least one of the entities. Okay, so this is done. I think we are good for now. Probably in the next discussion, I'll go a little bit deeper into the digital twin part of the discussion, particularly from the standpoint view of how digital twins can be utilized to solve the problem at hand. That is more important right now. Thank you for watching this out. Have a great day ahead.